This is Bitnar Talks, the engineer takes on construction. Episode 21. Hi, I'm Piotr Bitnar. Each day I help my clients plan and design building projects through Bitnar Limited, a consulting chartered structural engineer's practice. My biggest passion and the cornerstone on which I've built my business is finding clever solutions for construction projects. I am a chartered structural engineer and a budding software developer, so you can rest assured that I will strive to talk about the best practices and the use of new technologies in the industry. And if you're embarking on a construction project or are involved in planning, designing and building the world around us, you'll find this podcast useful. Approved document D and E, toxic substances and resistance to the passage of sound. Hi, and welcome to Bitnar Talks, your favorite podcast on all matters of architecture, engineering and construction. It is Thursday the 20th of June 2024, and I'm here back with you with the 21st episode and information on approved document D and E, toxic substances and resistance to the passage of sound. Last week, I covered aspects concerning the approved document C, site preparation and resistance to contaminants and moisture. I thought we'd start this episode, as ever, with some recap points from that episode. And these are: number 1, designers and contractors must ensure adherence to building regulations, especially in flood-prone zones or contaminated areas. I'm sorry, I didn't know will not work here anymore. There are other relevant legislation that needs to be looked at, and these are the Contaminant Land England Regulation 2006 and the Environmental Protection Act 1990. Point 3, building sites must be free from harmful material to avoid health and safety hazards from contaminants like corrosives, explosives, radioactive materials, or toxic substances. Structural integrity is important, so building walls, floors and roofs must be protected against ground moisture, precipitation and condensation. Sites need to be evaluated through planning, desk studies, walkover surveys, sampling and testing. Further guidance is provided in BRE Digest and NHPC publications for impact assessments and remediation solutions. Common contaminants are like asbestos, radon, sulfates, biodegradable waste, pesticides and hydrocarbons. Risk assessment procedures involve preliminary risk assessment, go into generic quantitative risk assessment, and then if need be the detailed quantitative risk assessment. Contamination management options include treatment, containment or removal, and the guidance can be found in SERIA or NHBC or the Environmental Agency publications. Subsoil drainage may be present on site or may be required to direct and we may need to put some pipes in the ground to direct that groundwater away from the building and its services. Floors must prevent ground moisture transfer, condensation, and typically include a vapor barrier, insulation, and a damp-proof membrane in the build-up. Ground-bearing slabs should be at least 100 mm thick with appropriate damp-proof membranes. Suspended floors need ventilation and isolation from the ground moisture. Walls must prevent moisture ingress and mitigate condensation. Roofs must meet similar standards as walls and floors to prevent moisture and condensation. These points are general guidelines that ensure the buildings are safe, resistant to contaminants and moisture, thereby protecting the structure, services, and most importantly the occupants. In this episode, I will move to the approved document D and E and the consideration for the cavity insulation and soundproofing. So without further ado, let's dive into the text of the approved document D and E. this episode, I'll talk about the statutory guidance contained within the approved document D&E, toxic substances and resistance to the passage of sound. The approved document D is fairly short and sweet, and mainly concerns the use of urea formaldehyde foam cavity insulation, and the document E gives us a prescription of build-ups and procedures to assure sound insulation and dampening of reverberation. So let's not faff about and start the listening bout. As ever, we'll be starting with the text of the actual requirement. So approved document D, toxic substances, requirement D1, cavity insulation. If insulating material is inserted into a cavity in a cavity wall, reasonable precautions shall be taken to prevent the subsequent permeation of any toxic fumes from that material into any part of the building occupied by people. The onus here is placed on materials that give off formaldehyde fumes during application and or typical use and concerns its impact on the occupants. Urea formaldehyde compound is the main concern here, but do not fret, you may be likely having it mixed in your vegan wool products also. It is the nature of the material that it is off-gassing, therefore there needs to be enough separation in the building to limit the passage of the irritant to habitable rooms. The health and safety regulator is satisfied that the requirement is met if the cavity wall leaves are of masonry construction, wall is assessed to BS 8208, the person carrying out the work is certified, and the material accords with BS 5617 standard installed to BS 5618 standard. So a heavily standardized process. The requirement D is short and sweet. So let us move to the requirement E, starting with wording of the legislation. Part E, resistance to the passage of sound. Protection against sound from other parts of the building and adjoining buildings. Requirement E1. Dwelling houses, flats and rooms for residential purposes shall be designed and constructed in such a way that they provide reasonable resistance to sound from other parts of the same building and from adjoining buildings. Protection against sound with a dwelling house, etc. Requirement E2. Dwelling houses, flats and rooms for residential purposes shall be designed and constructed in such a way that A. Internal walls between a bedroom or a room containing a water closet and other rooms, and B. Internal floors provide reasonable resistance to sound. Requirement E2 does not apply to A. An internal wall which contains a door, B. An internal wall which separates an ensuite toilet from the associated bedroom, C. Existing walls and floors in a building which is subject to a material change of use. Reverberation in common internal parts of buildings containing flats or rooms for residential purposes. That's requirement E3. The common internal parts of buildings which contain flats or rooms for residential purposes shall be designed and constructed in such a way as to prevent more reverberation around the common parts than is reasonable. Requirement E3 only applies to corridors, stairwells, hallways and entrance halls which give access to flat or room for residential purposes. And requirement E4, acoustic conditions in schools. E4.1, each room or other space in a school building shall be designed and constructed in such a way that it has the acoustic conditions and the insulation against disturbance by noise appropriate to its intended use. And 2. For the purpose of this part, school has the same meaning as in Section 4 of the Education Act 1996, and school building means any building forming a school or part of a school. As ever, the requirements are straightforward, and the interpretation and guidance of approved documents irons out misconceptions. First one of which is what is the room for the residential purposes, which basically means any room that is used to live and sleep in. but does not include a hospital or similar patient accommodation. Regulation 41 tells us we need to test the sound insulation of the building when we make certain material changes to it, or it is a certain new building. Testing and recording data needs to be done to the approved method and the result conveyed to building control or the regulator within 5 days of completion or at the completion certificate application, respectively. Dwelling houses and flats may be exempt from this regulation if they use details approved by Robust Details Limited and they notify the building control of it no later than the prescribed times which coincide with the application for building control approval or notice of intention to start. Now, the approved document consists of 9 sections, sections 0 to 8, that are well worth looking into. Section 0, Performance Standards. In this section we are given the parameters for walls, floors and stairs that are deemed satisfactory for all the different circumstances, and we are told that it is preferred to test the construction rather than to rely on approved robust details. But nevertheless, this route is also available provided appropriate notification and the right time is given to the building control authority. Naturally, testing needs to be done by a test body with third-party accreditation, and they will be looking into some certain levels of sound reduction. They have different names and different abbreviations, and I'll tell you them right now. The abbreviation DNT, W stands for Standard Average Sound Reduction. On site, I should add Standard Average Sound Reduction. And DNT, W plus CTR, that's Standard Average Sound Reduction, but adjusted by low frequency performance. RW and RWCTR are laboratory equivalent measurements. LNW is the impact transmittance laboratory test, and LNTW impact transmitted on-site test. Generally, the minimum target levels are at between 43 and 45 decibels for airborne sound adjusted for low frequencies and site tested, and 62 to 64 decibels for impact sound insulation testing on site, to 40 decibels for lab tested build-ups. By the way, it is the Secretary of State's view that the requirement E2 is satisfied by the use of construction of elements that performance are confirmed by lab testing without the need for on-site verification. Similarly, with the requirement E3, we are directed to use of solutions of Section 7 of this document to satisfy the requirement. When it comes to schools, we are kindly referenced to use Building Bulletin 93, Acoustic Design of Schools Performance Standards, published by the Department of Education. Section 1, Pre-completion testing. So the person responsible for testing is the person doing the work. We shall test purpose-built dwelling houses and flats, or these formed by the material change of use, including the creation of residential purpose rooms in the buildings that otherwise didn't have it before. Do not test between living spaces or corridors, stairwells or hallways, but test between the rooms and complete rooms without finishes, including flooring. For testing, it is essential to group testing into building types, habitable types, and further subgroup by the characteristic of the space and wall and floor build-ups, and test these to inform the quality of the build-up for the same group and subgroup in the development. This will allow testing of every 10th dwelling house, flat or residential room in a group or subgroup, but every first of the given group or a subgroup. Now, whether we test floors or walls, we ought to think in two sets of tests, if possible, between living spaces and between bedrooms. The timing and manner of testing should be consulted with the building control body. When the particular group or subgroup fails the test, it may be necessary to test other similar types of buildings and rooms as well as to remediate the issues. The guidance sent us to BRE information paper IP14/02 for further information. In any case, we will need to liaise with the building control to satisfy them of the quality of the remediation work at the particular place of failure, but also at the remaining lot of buildings, flats and rooms at that group of build-ups. You see, if one failed, all of them may be bad altogether. So a consensus and the way forward needs to be found between the developer, between us, and the building control, so we can assure that the actual details are fine, and maybe this was only one particular spot place, a build-up that was faulty. Going to section 2, separating walls and associated flanking construction for new buildings. The guide gives 4 wall types for us to choose from, typically solid wall, cavity wall, solid wall with independent panels on either side of the wall, and independent frame walls with insulation. Flanking noise passage is an important consideration at the junction of walls, especially with dissimilar construction or where walls are tied together. The guidance even specifies dynamic stiffness limits for wall ties to limit the passage of sound between the leaves of the cavity wall. It requires doors to be at least 25 kilograms per meter square heavy or have RW of 29 decibels. Noisy parts of buildings would ideally be separated from the habitable parts. The guide goes on to stipulate densities of walls for refuse chutes, solid walls, cavity and paneled walls of different materials which consequently requires the wall to be at least 200 mm thick. The guide pays particular attention to sealing the flanking gaps, including those hidden within cavities. Section 3. Separating floors and associated flanking construction for new buildings. Similarly to Section 2, the guide treats on floors, giving us 3 types to use: solid floor with floating slab, and separated timber frame. And three types of ceiling treatments. Treatment A, independent ceiling with absorbent material, typically minimum 100 mm gap, filled with 100 mm of mineral wool. Insulation of density at least 10 kilograms per meter cubed, and 2 number of staggered plasterboards of density at least 20 kilograms per meter squared. Type B, single layer of plasterboard fixed to timber battens through resilient metal bars with the cavity filled with mineral wool. And Type C, similar to Type B but without resilient bars, possibly with resilient channels, but then the space will need to be infilled with the mineral wool also. In any case, junction detailing and typical requirements are shown on the diagrams and further detailed in the text of the guidance. Picture says 1,000 words, and I do not have enough tea ready to speak about every single picture that is available in the documents, as there are tens of them. The word of advice, the simpler the method, the better. I'm always pro solid floors due to the impact insulation and the thermal mass, but the British fast housing trends tends to prefer separated timber with the mineral wool option. Section 4. Dwelling houses and flats formed by material change of use. It is generally understood that if the existing element is within 15% of mass per unit area designated for the element in section 2 or 3, the element is likely sufficient. But there are guidance for approved improvement works that may be sufficient if the wall floor isn't sufficient as is in situ. Naturally, there are alternatives and proprietary products that may be used instead. As ever, it is important to identify any continuities of floors and possible flanking passage of sound. The remediation is generally done by either increasing the mass per meter square of the build-up or adding a separate panel with mineral wool absorbing layer, assuring enough separation between the old floor or wall and a new panel. Section 5. Internal walls and floors for new buildings. Internal walls and floors follow similar consideration but as that one of the other sections, but their density requirement is vastly reduced, allowing for the minimum wall thicknesses of 75 millimeters and floors of uniform build-up, not requiring separation of suspended ceilings or floating floors. Section 6. Rooms for residential purposes. There is not much philosophy added to residential purpose rooms. They need to follow the already mentioned requirements. Section 7. Reverberation in the common internal parts of building containing flats or rooms for residential purposes. Reverberation is an interesting one, and it concerns the transition between the access hallways, corridors, stairwells and entrance halls, and flats and residential rooms. The subject can be approached by using one of the identified methods. Method number 1, either by using absorber of an appropriate class rated according to BS EN ISO 116545, that be class C absorber or better for the area of horizontal plane anywhere in the space that faces the area, which can be a ceiling, and class D for stairs areas but reduced to 50% of the area if we choose to use class C absorber material. Or method 2, which is calculation method, and we need to calculate the required minimum of absorptive material using calculation procedure in octave bands. So for all different frequencies of sound, that be low to high pitch, we need to calculate all of the relevant areas and applying the most onerous one to our circumstance. That be octaves between 250 Hz and 4000 Hz. The minimum absorption area to be anyhow 0.2 meters square per cubic meter of volume for entrance halls and 0.25 meters square per cubic meter of volume for corridors and hallways. To satisfy the requirement, a description of the enclosed space by type and either the resultant specifications from the method A or B needs to be stated on drawings or within a report, together with plans indicating the assignment of the absorptive material in the enclosed space. The guide goes as far as it shows a work example to follow. So it's very good. I recommend you have a look at that working example. It will make everything so much more clear to you. Section 8, acoustic conditions in schools. And that one isn't a long one. Unfortunately, in this section there are no particular directions apart from the reference to the Building Bulletin 93, Acoustic Design of Schools Performance Standards. And yeah, you basically need to go there and follow that. So this is it, folks. The approved document D and E, toxic substances and resistance to the passage of sound. Let's sum it up. Approved document D, toxic substances, requirement D1, cavity insulation. Remember, when insulating material is inserted into a cavity wall, measures must be taken to prevent toxic fumes, especially from formaldehyde, from permeating into occupied parts of the building. This can be prevented by ensuring that cavity wall leaves are of masonry construction, assessed to BS 8208, installed by a certified person, and the material that you inject conforms to BS 5617 and BS 5618 standards. Approved document E, resistance to the passage of sound, got 4 requirements, E1 to E4. E1 deals with sound from other parts of the building and adjoining buildings. And it says that design and construction of the element must provide reasonable resistance to sound from other parts of the same building and adjoining buildings. Requirement E2 deals with sound within a dwelling house. Internal walls and floors must provide reasonable sound resistance, especially between bedrooms or living rooms. Requirement E3 deals with reverberation in common internal parts. Design and construction must prevent excessive reverberation from corridors, stairwells, hallways, and entrance halls in buildings containing flats or rooms for residential purposes. Requirement E4 deals with acoustic conditions in schools, and it deals with it by referencing us to have a look into the Department of Education Standards. Regulation 41 tells us about sound installation tests, testing and compliance. Sound performance of the elements of the building must be tested and data recorded for certain material changes of use and for new buildings, with results submitted to building control. Exemptions may apply if using robust details, limited approved methods, and taken the building control has been notified of this preferred route beforehand. Going section by section now. Section 0 sets performance standards for walls, floors, and stairs. Detailed parameters for satisfactory sound installation, recommending testing over relying solely on robust details. Section 1 describes pre-completion testing, and it recommends testing for different building types and groups to ensure quality, but to avoid the necessity to test every single build. Section 2 sets the scene for separating walls. It provides guidance on typical wall types and flanking consideration in any given construction to limit sound transmission. Section 3, separating floors, gives similar guidance to floor types and ceiling treatments. Section 4, material change of use, offers approved improvement solutions and works for existing elements. Section 5, internal walls and floors, follows similar consideration of previous sections but reduce density requirements for internal walls and floors. Section 6, rooms for residential purposes, extend previous consideration to residential purposes rooms. Section 7, reverberation in common areas, gives methods and a working example for the management of reverberation in common areas of residential buildings. Section 8, acoustic conditions in schools, refers us to Building Bulletin 93 for detailed guidance. In the next episode, we will move to approved document F, Volume 1, Dwellings, and Volume 2, Buildings Other than Dwellings, when it comes to ventilation. I hope you enjoyed this episode and that the consideration of the approved document D and E, toxic substances and resistance to the passage of sound, is now clear for you. If you have any questions, reach out to me on LinkedIn or send me an email. I'm more than happy to help you out. In Bytna, we deal with planning, designing and managing of your projects, and we are always glad to facilitate a free initial consultation to steer you in the right direction. Visit www.bytna.co.uk and reach out to us. Whether your question is if we can help you with your project or what should I do, we will be able to give you a piece of non-obligatory advice. At Bytna, we help our clients design and execute their dream homes or investments. If your building is falling apart, we can also help investigate the reasons behind it and to provide you with an approved strategy, design and specifications for the repair. Thank you again for listening. Please voice up your opinions. I'm waiting for you on LinkedIn and I want to hear from you. See you next week. Remember, Bytna designs the world around you. Toodaloo.